introduction of how we move forward, and then I will introduce you, and then we will wait maybe 1 more minute, and then, or even not, I will just speak slowly, and then we will start. So the seminar will proceed as always with about 45 to 50 minutes with your presentation, and then we will have 10 to 50 minutes for questions, and then those who have to go will be free to go, and those who want to stay are more than welcome to stay for another informal discussion of about 15 to 20 minutes if it's fine with you. So now it's my great pleasure to introduce Professor Lejarraga. Thomas published in the very top journals, including PNAS, Management Science, OBHDP, Psych Bulletin, and much more. He is also a very important person as he serves as the director of the UIB Decision Science Laboratory. You will have to tell us more about what does it mean later. And now, without further ado, Thomas, the floor is yours.
Thank you, Yefim. Thank you for inviting me. And it's great to see so many friends among the ones that connected. So today I will talk about a project in which Ralph Hertwig and I explore how experimental methods can influence the way we see the human mind and how the way and how we judge rationality. Okay, so in 1955, Egon Brunswick wrote, "While God may not gamble, animals and humans do. They cannot help but to gamble in an ecology that is of essence only partly accessible to their foresight." Brunswick was among the first to acknowledge that if you want to understand the behavior of an organism, the behavior of an individual, you should direct your attention to the organism's environment as much as to the organism itself. And he was not alone with this idea. This idea of paying attention to the environment was also central in Herbert Simon's thinking. But Brunswick made another important observation. Brunswick observed that the environment is uncertain and probabilistic. So for Brunswick, adapting to the environment, being functional in an environment, meant that organisms, individuals, had to learn the statistical structure of the environment. Not perfectly, but at least develop an intuition of the key relationships in the environment. So in the 50s and early 60s, one prevalent question was, how accurate are our statistical intuitions? How good are we at learning the statistical structure in the environment? One could argue that this question, or attempts to answer this question, gave rise to the field of judgment and decision making, which it is a precursor of what we now know as behavioral economics. So in 1967, Peterson and Beach reviewed practically all the work that attempted to answer that question. They looked at 2 decades of research, more than 110 articles, including more than 160 experiments, and they looked at a variety of tasks, a variety of judgmental, inferential, and predictive tasks. So they looked, for example, at work on what they called intuitive descriptive statistics. This is work on people's judgments of sample proportions, judgments of sample mean, variances. And one experiment, for example, in this class of tasks would be a participant draws a sample of cards from a deck of red and blue cards and is asked to make a judgment about the proportion of red cards in the sample. And performance in this task is assessed by comparing the intuitive judgment of proportion with the true proportion in the sample. Peterson and Beach also looked at intuitive inferential statistics. These are inferences from sample information to population parameters, for example, to population proportions, means, variances, and correlations. And here, the task would look like a participant draws some cards from a deck of red and blue cards, and is asked to make an inference about the proportion of red cards, not in the sample, but in the deck. And here, performance is assessed by comparing the intuitive inference with the optimal inference derived from a statistical model. Peterson and Beach also looked at intuitive predictions of samples, predictions from unidimensional or multidimensional populations. They looked at a lot of work. And let me show you one example of the tasks that they reviewed. The task is Bayesian inference, or belief updating, or Bayesian updating. And because Bayes theorem provides what is considered the normative or the rational behavior in this task. And this is an important task because updating beliefs based on limited information is a key process in navigating an uncertain environment. And it is also, and doing so in a Bayesian way is a central assumption in the rational choice framework. So this is a task by Ward Edwards and Larry Phillips. Larry Phillips was Edwards' PhD student in Michigan in the 60s, in the University of Michigan in the 60s. And Ward Edwards is considered by many the father of behavioral decision research. So the task goes as follows. One participant, this experiment was usually conducted one participant at a time. So one participant is shown two bags, and these bags contain red and blue chips. And the participant is told the exact proportion of red and blue chips in each bag. In this example, the bag on the left has 70% red and 30% blue chips, and the bag on the right has the opposite, 70% blue, 30% red. So we can call the bag on the left the red bag because it has more red chips than blue chips, and the bag on the right, the blue bag. Then the experimenter tosses a coin to select one of the two bags, and the participant knows this, but the participant doesn't know which bag was selected. And the experimenter asks, what is the probability that the bag picked is the red bag, the bag that has more red chips than blue chips? And here participant says 0.5, which is the correct answer. But then the experimenter draws a random chip out of the bag, shows it to the participant, and asks again, what is the probability that the bag picked is the red bag? Now, after seeing some evidence, the participant has to revise the probability that the bag picked is indeed the red bag. Without any evidence, the participant said 0.5. Now the evidence points in the direction of the bag being the red bag. So all the participant has to do is revise the estimate a little bit, revise it upwards a little bit. If he was Bayesian, he would say 0.7. Then a new chip is drawn, and this is done with replacement. And the participant again is asked to give a new estimate, and a new chip is drawn, and this is done repeatedly for 20 chips to complete one cycle, and then two new bags are shown, and 24 cycles are conducted. That means that by the end of this experiment, the participant makes a total of 480 estimates. Now, this task attracted a lot of attention. Edwards, but also others, studied this task extensively. They explored the influence of having more than two bags that didn't have symmetric contents. They explored different randomization devices, different response modes. Sometimes they asked about probabilities, other times they asked about odds, constructing different response devices. They were physical devices to respond, moving elements or physical elements to express probabilities. And after seeing enough evidence, Edwards concluded that opinion change, which is another name for Bayesian inference, opinion change is very orderly and usually proportional to numbers calculated from Bayes' theorem, but it is insufficient in amount. So for Edwards, people were conservative Bayesian. That is, people were qualitatively Bayesian, but did not revise the estimates as much as they should. They didn't give enough weight to the evidence as the evidence deserved. But in essence, for Edwards, people were close to Bayesian of a conservative type. So going back to the broader question of how accurate are our statistical intuitions, we know, or at least we now know, that in Bayesian inference, people seem relatively accurate. Bayesian, although conservative. But this is just one example, because remember that Peterson and Beach reviewed a whole variety of tasks. What was their conclusion? So after reviewing more than 160 experiments across a variety of tasks, Peterson and Beach concluded that experiments that have compared human inferences with those of statistical man show that the normative model provides a good first approximation for a psychological theory of inference. Inferences made by subjects are influenced by appropriate variables and in appropriate directions. So what Peterson and Beach are saying here is that if you want to model people's inferences, you should use statistics, use the optimal model, and you will approximate human inferences quite well. The review you may be familiar with was published in Psychological Bulletin, titled Man as an Intuitive Statistician, and the intuitive statistician in 1967 became the metaphor of the human mind. It is interesting to see how Peterson and Beach used the words of Brunswick that I used to open the presentation, but how they followed. So they write, while God may not gamble, animals and humans do. They cannot help but to gamble in an ecology that is of essence only partly accessible to their foresight. This is Brunswick, and they follow. And man gambles well. He survives and prospers while using the fallible information to infer the states of his uncertain environment and to predict future events. So in 1967, the view was that people were quite good at learning the statistical relationships in the environment. Almost simultaneously, Tversky and Kahneman were beginning to conduct their own experiments. So Tversky had just spent some time in Edwards' laboratory in Michigan and just joined the Hebrew University of Jerusalem, where Kahneman was a young professor. And Kahneman invited Tversky to give a talk to his students, and Tversky accepted. And Tversky talked about what he had learned at Ward Edwards' laboratory, namely conservative Bayesianism and intuitive statistics. And Kahneman did not agree with Tversky's story. He thought that he himself was not an intuitive statistician and that the metaphor felt wrong. This event is recounted in Michael Lewis's book about Kahneman's and Tversky's life. So they together went on to study human judgment in one of the most fruitful collaborations that we know of in psychology. And among the first problems that they studied together was Bayesian inference. And here's one of the problems that they used in their early research. Now, imagine now participants in this experiment receiving a piece of paper with the following text written on it. Consider two very large decks of cards denoted A and B. In deck A, 5/6 of the cards are marked X and 1/6 are marked O. In deck B, 1/6 of the cards are marked X and 5/6 are marked O. One of the decks has been selected by chance and 12 cards have been drawn at random from it, of which 8 are marked X and 4 are marked O. What do you think the probability is that the 12 cards were drawn from deck A? That is, from the deck in which most of the cards are marked X. So if you notice, the structure of the task is equivalent to Edwards' task. There are two sources of evidence. In Edwards' task, there were bags with chips of 2 possible colors. Now we have decks of cards with 2 possible marks. One of these 2 sources is selected by chance. Some evidence is randomly drawn, shown to the participant. The participant has to judge where is that evidence is coming from. And yet, this is what Kahneman and Tversky concluded. In his evaluation of evidence, man is apparently not a conservative Bayesian. He's not Bayesian at all. In other words, even though the task was structurally very similar to Edwards' task, Kahneman's and Tversky's conclusion could not be more opposite. Now, Kahneman and Tversky went on to study other domains of judgments, inferences, and predictions, and 2 years later, but 4 important papers later, they summarized their new and revolutionary view. People rely on a limited number of heuristic principles by which they reduce the complex tasks of assessing likelihoods and predicting values to simpler judgmental operations. In general, these heuristics are quite useful, but sometimes they lead to severe and systematic errors. And their paper was published in Science. Many of you may be familiar with this article, titled Judgment Under Uncertainty, Heuristics and Biases. And this paper profoundly influenced psychology, but also economics, finance, management, and the law. And the ideas introduced in this paper were recognized twice in the Nobel Prize of Economics, once to Kahneman, once to Thaler. And notice that there are 2 ideas here: heuristics and biases. And I would argue that the idea of heuristics didn't have as much of an impact as the idea that people are biased and prone to error. And soon, several best-selling books were published describing human error. And although for Tversky and Kahneman, heuristics only sometimes leads to severe and systematic errors, for others, like Thaler, mental illusions should be considered the rule rather than the exception. And you know the story that followed. So here we have the cumulative frequency of citations for the 1974 Heuristics and Biases article, and for Man as an Intuitive Statistician by Peterson and Beach. And it is very clear how the new view drove the intuitive statistician out of sight. The same happened with Not Bayesian at All and Edwards' paper on conservative Bayesianism. So only 7 years after the publication of Peterson and Beach's comprehensive review, the intuitive statistician was quickly forgotten. In fact, many are not even aware that it ever existed. Now, the shift in view had a spectacular impact, not only in science, but in policymaking. The view that people make predictable errors is the basic tenet of Nudge, the book that proposed the idea of libertarian paternalism, and to the creation of behavioral insight units all over the world, many of them operating under the assumption that people are in some way flawed. So here are some quotations from the first few pages of the Nudge book, where the theoretical pillars of the approach are established. And so human predictably err, human forecasts are flawed and biased, human decision-making is not great either, but we often make mistakes, and so on. So we ask, what happened? How could experimental psychology in one short period support such diverging conclusions? How could almost 2 decades of experimental evidence in favor of the intuitive statistician be forgotten so uncritically? So to attempt to provide some answer to these broad questions, let me first talk about the description experience gap that many of you may be familiar with. So whenever we want to study how people make decisions under risk, or how much they like risk, we may use questions or decisions like this one here. Choose the option that you prefer: 4 euros with 80% chance, 0 otherwise, or choose 3 euros for sure. If I give people several of these problems, we may learn something about their willingness to take risks. But in 2004, Ralph Hertwig, Ido Ereb, Greg Barron, and Elke Weber explored an alternative way of studying how people make decisions. Instead of describing the options to participants, they gave participants 2 buttons and asked them to make a choice for a payoff. But since participants had no information about what these buttons offered, they were told that they could sample these buttons as many times as they wanted. Sampling means clicking on these buttons, and then a click would reveal a payoff. The participants could click as long as they wanted until they were ready to make a choice, and then they would make a final consequential choice. Now we refer to the first type of class of decisions as decisions from description because options are fully described, and to this class of decisions as decisions from experience. Now it turns out that decisions from description and decisions from experience led to systematically different choices. And there are several reasons why choices differ in these two paradigms. But to make a long story short, decisions from description are best captured by prospect theory or by Kahneman's and Tversky's prospect theory, assuming overweighting of small probability events, loss aversion, risk-seeking in gains, and risk aversion in losses. And decisions from experience are better captured by learning models that are able to capture the sequential processes, sometimes assuming reliance on small samples, but overall, generally more aligned with expected value maximization, as Dirk Wolf has shown in his meta-analysis.
Objection. I disagree with this. This is what we'll find in that paper. We'll return to that later. Just you accept my objection. This is this is not the way I understand that paper.
Okay. So we go back to that at the end, either.
Yes.
Okay. So so the question is, can the description experience distinction help us understand these contradicting conclusions in the early 70s? It is as if the observation of the description experience gap gave us a new perspective to look at this old unresolved problem. So if we go back to Bayesian inference, what we see is that this is how Kahneman and Tversky studied Bayesian inference, description-based, and they observed people are not Bayesian at all. This is how Edwards studied Bayesian inference, largely experience-based, and he observed near Bayesianism. So is this apparent description experience gap in Bayesian inference an isolated case, or is it a more general phenomenon in the literature? So what we did with Ralph was to look at each experiment within each paper reviewed by Peterson and Beach, and to examine whether the experiment was more description-based or experience-based, and compare that to the experiments conducted by Kahneman and Tversky in their first 4 papers that were later summarized in their 1974 Science article. And so what we did is we coded for dimensions that we thought captured the experience description distinction. So for example, we coded whether the experiment involved feedback, whether it involved practice trials, whether the stimuli was physically present in the laboratory or invoked descriptively, whether participants gave one response or more than one response, whether the stimuli were objects or whether it was people, and other dimensions like other aspects like incentives, participant type, etc. And this is the volume of work that we looked at. So 81 primary experimental papers by Peterson and Beach, and 4 by Kahneman and Tversky that included 163 experiments and 30. And here is the percentage of studies in the analysis across the attributes that I just mentioned. I'm assuming you see the cursor, okay? Okay, so yes, what we observed was a clear difference in methods between the intuitive statistician tradition and the heuristics and biases tradition. So here we have the intuitive statistician methodological profile in the empty circles, and the heuristics and biases methodological profile with the filled circles. And what we see is that experiments in the intuitive statistician involve feedback in more than half of the cases. Many of them involve practice. Most experiments involve stimuli that is physically present that are physically present in the laboratory. Almost all experiments require more than one response, and almost all experiments were dealt with objects like cards, balls, urns, dice. Experiments by Kahneman and Tversky in those first 4 papers involved no feedback, few opportunities for practice. Stimuli were almost always invoked descriptively. Participants gave more than one response in most of them, but experiments tended to be about people rather than objects. We then counted the number of responses, and in the intuitive statistician, an experiment gives on average 77.5 responses, and in the heuristics and biases tradition, a participant gives a median of 3 responses. So what we observed was that before Tversky and Kahneman, experiments were more experience-based and involved chips, cards, balls, urns. And Tversky and Kahneman introduced experiments that were more description-based and involved people. Now, one question you can ask is, what was Kahneman and Tversky's impact on the experimental protocols in the study of judgment and decision-making? And as I showed, the JDM field grew very rapidly in several directions. So what we did is we first looked at Bayesian inference as a representative case and conducted the same analysis that I just showed. So what we did is we looked at Koehler 1996, a review of Bayesian inference published in Behavioral and Brain Sciences. And that review includes 70 papers that are primary experimental work. And these 70 articles include 180 experiments. And we did the same analysis as before. And what we observed, so here we have Koehler 1996, the dark square in black. And what we observed was that experimental methods in Bayesian inference, after the introduction of the heuristics and biases view, adopted very similar methods as those in the heuristics and biases tradition, namely largely description-based methods, with very few cases where feedback is provided, few cases in which practice is allowed or practice is reported. Stimuli tend to be descriptively invoked, and so on. The median responses in the Bayesian inference studies was 7, close to the heuristics and biases median, far from the intuitive statistician. We also looked at other domains of judgment. We looked at the conjunction fallacy, largely popularized by Kahneman and Tversky, and to anchoring and adjustment and framing, both introduced by Kahneman and Tversky. These are the number of experiments that we reviewed, and we conducted the same analysis, and we observed was largely description-based methods with little or no feedback, with very few opportunities for practice, and stimuli where people invoked descriptively. And the median number of responses was low, 16, 7, and 4.5, closer to the median of 3 in the heuristics and biases tradition, and far from the 77. So the picture that emerges is that Kahneman and Tversky introduced a description-based method in the study of judgment and decision-making and had a broad impact in experimentation practices. And these are the experimentation practices that underlie the current view of people as biased and prone to error. Now, our literature review shows a strong association between experimental practices and statistical competence, but it is not causal evidence. The gold standard for causal evidence are experiments. But doing experiments for the variety of tasks that we looked at was beyond what we could do. But it turns out that in the last few decades, or couple of decades, researchers have independently conducted experiments to address the question of whether biases disappear with experience or are reduced with experience. And they have done so for a variety of tasks. So with Rationality Hertwig, we reviewed the literature, and here is a partial list of the biases that indeed decrease or disappear with experience, or that even reverse with experience. So we know that errors in Bayesian inference are reduced with experience. Errors in probability judgment, work by Robin Hogarth and Emre Sawyer, they show that, for example, in the birthday problem, people who learn from experience do it significantly better. Work by Eldad, Yehiam, and Hochman show that loss aversion practically is never observed in decisions from experience, and so on. The certainty effect is reduced, reflection effect, the conjunction fallacy. And there are several biases that disappear or that are reduced with experience. Now, let me clarify that this does not mean that experience always leads to competence. This is not the claim. Biases do emerge in learning from experience, but these biases are usually caused by the type of experiences that people have. So in certain environments that Robin Hogarth called wicked environments, people may be able to only have a few experiences, or the experiences that they have may produce biased or delayed feedback, or no feedback at all. Or the environment may be too noisy to detect the signal and to learn. So in these wicked environments that are not conducive to learning, then experience may lead to error. But in these experiments that we include in this list, experience tends to be kind, tends to be abundant, and feedback tends to be unbiased. Now, an alternative way to study whether there is a description and experience gap in statistical intuitions is to ask, what do we know about the statistical skills of those who do not yet possess the ability to learn from description and must learn for the most part from experience? And this is a question that Christine Schulze and Ralph Hertwig addressed, both experimentally and in conducting a literature review. And I am referring, of course, to babies. Babies cannot read descriptions and must learn, at least for the most part, from experience. And so before telling you what Ralph and Kristen found, let me share with you an experimental paradigm used by developmental psychologists to study statistical intuitions in babies. And this is a task by Xu and Garcia. It is a really interesting task. So the baby sits in front of the experimenter, and the experimenter has a box on the table. And the experimenter pulls a ball randomly from the box and shows it to the baby. And then the experimenter does it again and again sequentially for the baby to see a random sample from the box. Notice that the baby is learning very much like participants in Ward Edwards' experiment. Now, in one condition, when the experimenter opens the box, the baby sees a content that is very much expected from what he has seen in the sample. But in another experiment, in another condition, when the experimenter opens the content of the box, opens the box for the baby to see the content, then the content doesn't look familiar. And the baby looks at the content of the box and doesn't look away that quickly. The baby looks puzzled. And Xu and Garcia measured looking time, and indeed they found that babies look much longer in the unexpected, when the content of the box is unexpected, than when the content is expected. So much so that you can take the looking time as a measure of relatedness between sample and population. And with this and similar variants of this task, developmental psychologists observe intuitive statistics across the board, in 8-month-old infants, in 12-month-old infants, in 16-month-old infants. Now, how can babies be so good and adults be so bad? This is the question that Ralph and Christine ask. By now, you should expect that it must be a problem, or at least some part of the answer should be related to the way babies and adults learn. So Ralph and Christine gave now children aged on average 9 and adults aged on average 26. They gave them the same Bayesian inference problem, and children were better than adults, but only when children learned from experience and adults from description. When adults learned from experience, they were much better than children. And when children learned from experience, they were worst of all. And they replicated this result for the conjunction fallacy. There's also some research that shows that people that have been looking at intuitive statistics in capuchin monkeys, bonobos, chimpanzees, and apes, they generally observe intuitive statistics, and even some species of parrots. So what have we learned? What we have learned is that experimental methods are key to what we conclude about the rationality of human statistical intuitions. Experience-based methods are more closely associated with better statistical intuitions, and biases and error are more probable in description-based methods. The issue is not so much who is right and who is wrong. I think that a comprehensive view of human rationality must include both learning from descriptions and learning from experience, because both are part of our human ecology. Now, the story I just told you was not constrained to any particular field of research. We looked at all the articles reviewed by Peterson and Beach, all the articles, all the work by Kahneman and Tversky in their early period, and we reviewed all the articles by Koehler. But turns out that this story happened mostly in psychology and to a lesser extent in management journals, and also to some extent in law journals. But of course, the experimental method is prevalent in some areas of economics, and rationality is a central concept in economic theory. So we wanted to explore how this story unfolded in economics. And to have a better appreciation of how this story unfolded, it is important to talk about an important player in the emergence of experimental economics. And I'm referring to Sidney Siegel. So Siegel was a psychologist who died young, but was briefly active and very, very influential in the 50s and 60s. And Siegel believed that participants should never be deceived, that they had to be adequately paid, and that their experience and learning was important. In fact, some of his work was in probability matching, in which experience and learning are important. But he also did some work on non-parametric statistics. But it is important that Siegel influenced Vernon Smith, who then later documented a set of precepts for conducting rigorous economic experiments. And these precepts capture the spirit of Siegel's ideas. And here I have to thank Roy Sultan, who pointed me to this key player in the emergence of experimental economics. Now, so important was Siegel in Vernon Smith's thinking that in a symposium in honor of Vernon Smith, Smith dedicated the talk to Sidney Siegel. And there he recounted a very interesting event. So Smith writes, in the context of one of the discussion wherein the rigor of experimental psychology study came up, it was natural for me to blurt out whatever became the tradition of Sidney Siegel in psychology. In reply, Amos Tversky quipped, "You are it." So it turns out that, or at least this is what Smith recounts, that Tversky saw in Vernon Smith an experimental tradition that was a continuation of Skinner's behaviorism, very much focused on experience and learning. And this tradition treats the mind as a black box. And Kahneman and Tversky were trying to distance themselves from that approach, attempting to look into the black box, proposing and testing cognitive processes. Now, for some, this event illustrates a departure between what later became behavioral economics, following up on the work of Kahneman and Tversky, and what later became as experimental economics, following up on Siegel and Smith. So this is an important event in the early days of experimental and behavioral economics. Now, Kahneman and Tversky's observation that people are not Bayesian at all had important implications for economic theory. So eventually, economists stepped in and studied Bayesian inference experimentally, and the earliest reference of Bayesian of research on Bayesian inference, of experimental research on Bayesian inference published in an economics journal is Grether 1980. And Grether writes in the abstract of his article, in revising beliefs, individuals ignore prior or base rate information contrary to base rule. So he's referring to Kahneman and Tversky's work. Flaws in the evidence in the psychological literature are noted. An experiment avoiding these difficulties is designed and carried out. So we ask, how did economists study Bayesian inference? And what was Kahneman and Tversky's impact on experimentation practices? And how do they see people's Bayesian inference skills? What do they conclude about their Bayesian inferential skills? So we again conducted a literature review following the same coding protocol as before. And now we examined all the literature studying Bayesian inference that is published in economics, that used the experimental method, and that either cited Edwards' work on Bayesian inference, Kahneman and Tversky's work on Bayesian inference, or Grether's work on Bayesian inference. And we identified 56 articles that included 65 experiments. And of the papers retrieved, most of them cite Kahneman and Tversky, only a minority cite Edwards. Edwards was not as popular as Kahneman and Tversky in the study of, or didn't influence economic research as much as Kahneman and Tversky did, as reflected by this pattern of citations. And here you can see the influence of Grether, the first study within economics, more frequently cited than Edwards and Kahneman, roughly together. Now, what did we observe? How were the methods like? So when we looked at experiments, what we observed was that in Bayesian, this is how I called the experiments that we reviewed in the economics literature. We call them Bayesian economics. So this is the result of the literature review, and in green, blue, and red, the results that I already presented before. So what we see is that experiments in studying Bayesian inference within economics used feedback to a larger extent compared to all the previous work. Not many occasions where practice is reported. Stimuli are almost always invoked descriptively. Participants are given more than one response, and stimuli tend to be objects. So what we see is that the methods did not fully embrace Kahneman and Tversky's method, in particular because there's a lot of feedback, a lot of instances where feedback is provided. But what we see is a mix of methods here. But perhaps the most important difference is that in an experiment in Bayesian inference in economics, a participant gives a median of 50 responses, and compared to 7 in psychology, and similar and far from the 3 in the heuristics and biases tradition. So in short, experiments in Bayesian inference in economics are more aligned with Siegel's and with Ward Edwards' tradition than with Kahneman and Tversky's methods, even though Ward Edwards is not as acknowledged as Siegel is. Now, what follows is, okay, given these methods, how do they view people's competence? And the short story is that the view is mixed. It's not unequivocally negative, as in psychology. So some papers, about a third of the papers, conclude that people's inferences resemble or align with Bayesian, with Bayes' theorem. So here we have some examples. Posteriors are well approximated by those calculated using Bayes' rule. The majority of choices correspond with Bayesian updating, and so on. Other studies indicate mixed evidence. So here we have, for example, the majority of subjects, 54%, choose quotes that were in line with full Bayesian updating, while another non-negligible group behaved like maximum likelihood updaters, and so on. So many articles find mixed evidence, and yet many articles find no evidence. They see what they observe is bias. So the pattern is difficult to reconcile with Bayesianism and standard versions of confirmation bias, and so on. So what have we learned? So economists were drawn to the study of Bayesian inference by Kahneman and Tversky's view of people as biased and prone to error, but did not embrace their methods or their description-based methods as it occurred in psychology. Therefore, their conclusions do not unequivocally support the view of people as biased and prone to error, which is typically associated with description-based methods. So to conclude, what I think of what we've learned in these several literature reviews that we conducted is that experimental methods, in particular, the extent to which they allow people to learn from experience, are important to what we conclude about the rationality of human statistical intuitions. Thank you.
Okay, thank you, Thomas, for the very interesting talk. And now is the time for questions, and I think we will start from Ido's objection.
Yeah, it's not a very deep objection, and I already talked about it with Thomas, but since you mention it again, despite that I try to convince you this is not a correct argument, I just want to take the opportunity to say it again. And I'm saying that because, you know, in the 90s, I used to believe that experience will lead people to maximize and Kahneman, you know, all the your main point here, I used to believe in the 90s, but I changed my view. And I want to explain why I changed my view. So first, if you look at the data that Dirk has collected in that paper that you mentioned, he only showed that people are more like, doesn't show higher maximization rate in decision from experience. He just share more consistency what the subject do and what the way he behave. And when we study, for example, in the 2017 paper, when people can react both for description and experience, we found that when you add experience, sometimes it increases maximization, sometimes it decreases maximization. And we can predict it with a very simple model that says that what experience does is lead people to try to respond to pattern. So the idea that the people are less prone to error with experience is, I used to believe in it in the 90s, but my data, and this is 90 years of, not 90 years, I'm old, but not that old, 30 years of data, every time surprised me to say this is not the case. And I think that the person who really led the field in the wrong way is not the people who led the field in the wrong way are not Kahneman Tversky, but Tversky's teacher, Edwards. And Edwards' main contribution had many positive contributions, including leading psychologists to study decision-making. But he introduced one assumption that I'm sure that if he was alive, he would say this was assumption should be abandoned. And this is an assumption that you can study separately judgment and decision making. And I think that most of the biases in the field happens because of this separation. So I think that it's not that the description change people's behavior, but the way, if you separate the judgment from the decision making, then you emphasize a rare event, and all the big biases happen because of this emphasizing. So I agree with you that the field went in the wrong way, and I think there is something optimistic here. And now if I'll present a cynical view for a minute, I think the success of Kahneman and Tversky, and actually Kahneman talks about it, was really because these guys were smart and understood the incentives that researchers are rational. And basically what they say, you want to have a lot of citation, you want to start a field, try to find a paradigm that is easy to run, and then everybody will run experiments, will get tenure, and then will continue forever running these stupid experiments. And this is basically was trick. Let's have one line experiment. And in the 70s, this was really great. Many people got tenure, including me, probably, thanks to this trick. The good news is that nowadays it's really easy. These experiments are not easy to run anymore because now you run experiments in MTurk or in the web, and it's much, once you bring a subject, you have to pay some shop fee. Now it's much easier to run decision from experience. And this is why I think many of the people around here now understand that. And now the incentives go in our direction, and studying decision from experience is a good idea. But I don't think that blaming the method, the description part on the biases, or believing that experience now will move us toward rational choice is not exactly the case. And I think the problem, another problem, again, I think Edwards, was a definition of rational. This behavior is rational only under the assumption that the environment is static and the participant believe everything you say. What the subjects are doing, they are very smart, I agree with you. So our brain has a lot of neurons and we do a lot of computations. Not that we are stupid and using some stupid heuristics. But subjects do not try to maximize under the exact description. They are looking for patterns and do other things. So I think there's many important questions, and I think your analysis is very elegant historically. But I think the conclusion that that it should not, that I disagree with the conclusion that the main trick is a description experience gap I like, but it's not that when you have experience, then people are less prone to error.
Yeah, so I thank you, Ido. I try to clarify that that is not the claim. So what I believe is that judgment and decisions reflect the conditions of the learning environment. And in these experiments that well, this is a literature review, so we didn't conduct the experiment. So in these experiments, experience is kind, it's abundant. And so under those conditions, people tend to approximate the optimal choice. I agree with you that they not always do. For example, in cases where there are rare events and people don't come across them as frequently or perhaps never. So I don't think that experience leads to optimal behavior. I think it is more aligned, or it contributes to people behaving more aligned with the optimal behavior, but it doesn't clear away all the biases. Experience has its own, it can produce its own biases. That's one thing. Second, I don't think Kahneman and Tversky led the field in the wrong way. So what I think is they explored one particular type of inferences, predictions, judgments, and decisions, which are description-based behaviors. And I think knowing about how we perform in those areas, I think it's important. I think what we should not do is to generalize from behavior observed in those paradigms to behavior throughout. But I think we need to know how we behave in those settings, because possibly we may be encountering, as we collect more and more data in all sorts of domains, we may come across more and more situations in which we have to make decisions from description. So I think, I don't think people lead fields in the right or wrong directions. People study interesting problems, and now with hindsight, we can assess how they contributed, and I think they contributed in a way. But what I would say is they made several observations that we now know belong to the description to the description-based world. But thanks to, for example, to your research and Ralph and Greg Barron's research, that in a way revealed that learning from description and learning from experience can have important implications. Yeah, so that's
okay. Thanks. I agree.
Yeah, and by the way, the literature review takes the perspective of description and experience. We're looking at that particular distinction. Now, what happens within experience? We are not looking at, but I agree that there may be processes like, for example, I see Kinneret's hand up. There may be processes like searching for patterns or trying to detect and predict patterns. Yes, those processes may exist. I'm not claiming that people are computing averages. I'm saying that experience seems, given the literature review, seems to promote more rational behavior. Yeah, so Kineret.
Thanks, Thomas. I have many questions and comments, but we can stay later. I wanted to ask a more technical question.
Yes.
I don't know if it's technical. So can you upload again the slide with all the features of the feedback and with the economics? Because I was surprised by several things there. So I thought it might be good to ask about, yeah.
This one.
Yeah. So if I understand it correctly, you argue here that many of the economic studies use feedback. So, and this is, I find it surprising because, and the main question may be, I don't know, did you distinguish between, when you say number of responses, for example, in feedback, did you distinguish the cases per problem or the number of problems?
Okay, this is when we encountered, when we did the original study, it was very difficult to conceptualize what answers belong to one particular problem and not of another problem. So it was when we conducted the first literature review, it was very difficult to count the number of responses by problem. Okay, and so we decided that what we are going to count is any response. So, for example, if you have to make a choice, and then you have to give a confidence estimate, that counts as 2 responses. Okay, if you do that in 2 different problems, then you know the amount is 4 responses. Okay. So we did not this, we couldn't. You have to know that also there are all sorts of studies here. So, for example, in the Bayesian economics papers that we reviewed, not all papers are studying whether people are accurate Bayesian updaters. There are studies that are looking at how people consume information, for example, or studies that look at how people behave in a market entry game. And so Bayesian updating is part of the model. And so studies can be of all sorts. And in the intuitive statistician paper, studies are very, very varied. And we couldn't think of a way to conceptualize what is the unit of the problem and count the number of responses within that.
I
Let's go with
understand.
what
Just
we-
saying that this dimension might have distinguished between the pink and black lines here, right? So this
Can
would
you
be
repeat
like
that,
a very.
Meredith?
I'm saying that this dimension could have maybe, perhaps, distinguished between the pink and the black lines.
The pink and-
What
I take this measure as a proxy of how much feedback there was in this available in this tradition. Yeah, that's
I'm
the
just
way-
saying that if it's a feedback about like, but you get feedback, but you have many problems.
Okay.
It's a completely different thing than have one problem and a lot of repeated experiences.
Okay,
with ongoing feedback.
maybe this piece of information helps. We only counted feedback that can help you revise or improve or behave in a subsequent response. So we didn't count as feedback if you complete the task, you finish the experiment, and then I tell you how you did. That was not feedback.
I understand, but it still includes feedback from if you have different problems and you have one trial for each problem and you get feedback, it still can be useful. So in your coding, it will still count as the same feedback as if
Yes.
I have one problem. Okay.
Yes.
Okay, unfortunately, our time is running out. So I
Sorry.
want again to thank you. And now those who have to go can go. And we will be happy to stay for a bit longer. We still have some questions. And I invite those who can stay longer. So again, thank you. And now I hope I pronounce your name correctly. Seda, excuse me if not. Go ahead. We don't hear you. You have to unmute yourself. Yeah.
Sorry. It's Jada, by the way, but it's okay to call me Seda as well.
I'm sorry.
No, it's okay. When I saw, when you mentioned about like similar are objects and not people, I thought of emotions. Emotions are involved when we are talking about people rather than objects. So, how does different learning methods handle emotions? How differently they handle the emotions so that this may cause different kinds of biases, let's say. And secondly, again, when I looked at the number of practices, I thought of time. When you do practices, more time passes in between the stimuli and the decision. Again, for example, it may reduce the impact of, for example, let's say it's an emotion induction study, and it can reduce impact kind of things. So I would just want to hear your views on these.
So regarding the object versus people, I agree. These are two very different domains, and it is very possible that we recruit different processes to when we deal with social problems than when we deal with problems about dice. In fact, if you talk to evolutionary psychologists, this is the assumption, that we have domain-specific processes or rules. So I agree. The social domain has all sorts of important implications that we are ignoring here. So whether, for example, you trust the person or not, whether it's a potential ally, for example, or not, whether and we possibly have processes that track features that allow you to make inferences about these important social problems that will be absent when we're making decisions with cards, for example. So I think this is an important distinction. Now, why this distinction emerged, I don't know. But what I know from talking to people that were around those days, the idea that eventually psychologists or JDM researchers were beginning to study how problems with people, it was very welcome. My impression from talking to researchers again that were present in those days were that it was very boring to conduct experiments with balls, dice, urns, and that when Kahneman and Tversky proposed these experiments in which people are involved, then this was very exciting. This is one comment. This is your first point. Now, practice. I agree, but I would extend your point to experience more generally. When people experience a problem, they are spending more time. They are more time engaged. They receive more reinforcements, if you like, and it possibly triggers many different processes that are absent in these snap judgments that we make from description. So these are the possible causes for why experience helps. I agree. So experiments that allow practice, in fact, what they are allowing is it's another opportunity to learn about the problem, to familiarize. And so, but yeah, I agree.
So can we say that in a way, experience-based learning reduces the impact of emotions on our decisions?
I don't know. I probably wouldn't say so, because the experience that we are studying here are lab experiences. I'm sure that experiences outside the lab are much more emotionally charged.
Mm-hmm. No, we can't conclude that. It's a big conclusion.
Exactly. I wouldn't go there. In fact,
Yeah.
with Ralph and Robin Hogarth, we tried to characterize what experience is and what description is. It turns out it is a very difficult thing to do, because almost everything is an experience. Even reading a description is an experience. But we tried, in the context of the problems that we're studying, and we argue that experiences indeed carry an emotional component that is possibly absent from the description. And another important aspect is that experiences have coordinates in time and space. So you experience something at one time and in one place, and possibly that triggers emotional reactions. Now, descriptions then abstract an experience or a collection of experience and allow those experiences to be told and transferred and communicated to others. So one way to think about descriptions is that it allows experiences to travel. Yeah, so I think our argument is that experiences are more likely to carry emotions, and in fact, something that we also say is some effective descriptions are so because they approximate what experiences are. So if you think of some descriptions are richer, try to promote certain emotions, and if you think of for example, of a novel, of a short story, the descriptions that approximate experiences. Yeah, and that's my
Roy.
Thank you.
Roy.
Hi, thanks. Really interesting. So before I say what I want to say, let me comment on that. Experience is like getting realizations out of the distributions when we talk about statistics. So this mirrors a bit the difference between strategy method and play methods in experiments, and really behavior that depends on emotions, like punishment. We see it more in play method than strategy method. So there is a connection there. So first, I want to convey an anecdote, just an anecdote, but important, I think, which I happened to read yesterday from Dan Benjamin, who was here, but disconnected, who wrote that when he talked to David Grether about the 1980 paper, Grether said that he remembers that he cited Edwards, all the work by Edwards, and one of the referees asked him to take it out. So it's not a coincidence that you don't see these citations in economics. So that's the anecdote.
Do you have an intuition for why?
Because it was in psychology.
Okay.
So I don't know. So Tversky-Kalman cannot be avoided, but you still see today, unfortunately. So what I want to say was that you talk about methods, but the tasks are super important, right? So for example, if you think Tversky and Kahneman tried to look at similar problems to Edwards and came up with base rate neglect. In Edwards and Phillips, maybe always, but most of the time, the prior is uniform. If the prior is uniform, you don't get base rate neglect. So because base rate neglect in the Grether formulation, which comes from Edwards, is just saying base rate neglect people are Bayesian people who behave as if the prior is uniform. If the prior is uniform in the task, you will not distinguish Bayesian and base rate neglect. So and another quick example, which I also have data on, take another task. The task is ask people, what is your subjective probability that claim A is true and that claim B is true? Now I tell you exactly one of them is true, give me the probabilities again. And people in this task are surprisingly close to Bayesian. Okay. But in the Edwards task, they are far from Bayesian. If you play with the priors.
Yeah, so one observation is that in that experiment that Kahneman and Tversky sort of run with the same structure as Edwards, but description based. In that experiment, you don't observe base rate neglect. What you observe
no, you cannot. If the prior is uniform, you cannot observe base rate neglect.
Exactly, but this is not mentioned. What they claim is that people are not Bayesian at all. But in that experiment, they don't claim base rate neglect. You're right. Then they move on to different type of problems, engineer, lawyer problems, and then they.
Exactly.
Do you know?
But the priors is exactly the wicked versus kind environment, right? So if the priors are you have this rare event in the distribution, this is like have this implication it makes it more wicked, right? The environment.
Yeah, actually,
I
can show you.
No, it depends on the information structure.
So maybe I show you. Give me a second. Okay, I have to share again. So this is the problem that Kahneman and Tversky came up with. And so the problem I discussed is this problem here. 8 are marked X and 4 are marked O. Okay? And it's a problem where the content of the deck is five sticks in one type, 1/6 of the other, and the other problem has the opposite. And so, but they in fact they designed several problems where they vary the sample difference, 4-2, 4-8, and 40-20, and they vary the sample ratio, 18-14, 8-4, and 5. Okay, and so what they expect to see is that this is the answer, the median answer of participants, and what they see is that it doesn't change with the sample difference when it should. It practically doesn't change when it should, and it changes with the sample ratio when it shouldn't. Okay, and also it doesn't change with the P when it should. But if you look at how likely some of these problems are, so this is the probability of these problems occurring to that you actually observe 8-4, that you actually observe 18-14, that you actually observe 14-20. So as you say, Kinneret, some of these problems practically never occur, are very, very unlikely.
So maybe this is the issue, because I think that you do get a Kalman-Tversky result in decision from experience too. People, I have a data like that. If you have not looked at this data like that, I think that people do show little sensitivity to the average sample, to the proportion in the sample rather than to the difference in the sample. So I don't think the difference between Kalman-Tversky and Edwards et al. Was about description versus experience. I think it was just that they studied that what you just said. They study in the extreme situation that you can only study, that it's much easier to study in description, then you can see it. And when he studies a symmetrical kind of case, it's approximately Bayesian. But
Yeah,
on the corner, people deviate from the Bayesian predictions.
I think that there are several things going on. People that have zoomed into the experience versus description, like Spaniol and Ralph and Christine, that actually did the experiment in a controlled way where you only they see that the way you learn matters. Now, on top of that, I agree, there may be other phenomena going on.
The big phenomena is what you just said, the extremeness.
Oh yeah, so they are. This is what Brunswick refers to the bearded ladies. You know, Brunswick would say we have to sample the environment representatively, and not systematically. And but description allows you to come up with any problem you like, even if a problem is unlikely or if it's impossible. You can come up with a described problem and pose it to a person. Now,
but can you explain what Brunswick said? He said you should not study a rare event.
No,
events are really important.
He was a supportive of representative design. When we
but rare events are what's going to destroy our universe. We should study them, and what should kill you.
I agree. Some events that are unlikely to happen, then in a representative design will not be sampled.
But if the universe is destroyed, there's no point in making any inference.
Yeah,
there's no future.
But we can, okay. Good point. Good point.
I think there's another question by.
Yes, this is the time for the last question from, I hope I pronounce your name correctly, Silly.
Yes, Silly, very correct. Thank you so much. I really enjoyed the presentation and the discussion. I'm an economist, so I can pretty much also confirm this anecdotes regarding the citation, which is a shame. Anyways, my question is related to how should we think about different decision modes? So regardless of whether description versus experience, or let's say judgment and decision making that Ido was kind of alluding to, should we think about we as a human, we have different mode of decision when making decisions in different type of problems, or do we think about, let's say we have a unifying principle to make decisions, and then we make, let's say, conscientious switch accordingly?
Well, I think this is a very important problem that I can only try to say something useful. So people that have looked at, for example, description versus experience in risky choice, what they observe is that different models explain the behavior. So that's some evidence for the possibility that there are different processes going on in these two different domains. Now you can go even further. You can say, okay, going back to the question by Seida, is there a difference between the social domain and the non-social domain? I think there is. For example, I did some work on decisions from experience in the medical domain, hypothetical medical domain compared to a monetary domain. And there you see that the processes that better explain the decisions also differ. So I tend to think that different processes are deployed in different situations. the idea of a unifying model that works in every situation or that adapts well to the features of the environment, I see it as less likely. But I think this is one of the big questions.
You know why I'm smiling, right?
Yeah, no, I obviously disagree with this. Well, I think differently. I
How do
think
you
our
make
last
decisions?
our choice prediction competition shows the value of models that assume the same process, but you rely on different past experiences. When you start an experiment, you rely on all the experience you bring with you to the lab, and during the experiment, you start accumulating more relevant informations. And basically, the winner of our last two competitions assumes the same process. They do not assume two different processes. But obviously, it's this effect that it's an open question, a really interesting question. But I definitely think that all the decisions are from experience. When you start the study of decision from description, you rely on old experiences. When someone sends you an email, say, send me money, I'll send you back. You recall this is decision from description, but you really rely on past experiences that you heard about emails like that. So this is my view, which is Tomas and I have different views.
And also, but also in our, sorry, but just a short comment, also in our models, and if you think about people, for example, searching for patterns, so you can explain a lot of things with that, but we still use in our models two different mechanisms to search for patterns, and they are kind of, so I think it kind of depends on the resolution of the, so on the overall, you can say people sample using small samples, or people look for patterns. This is like a one unifying maybe mechanism, you can say. But then when you get to the predicting, you still need, even in this, in the winning models, you still have several mechanisms. And now the question is, sorry.
I think in the end, there's one mechanism overseeing other mechanisms. It has to be that way, right? Because we have one brain. Now, I think it has to do with the level of analysis. At what level are you proposing, whether there are several different modes, or is it only one? Because even if you have different modes, you need a mode that detects for which environment, which mode are you going to trigger. So I think this is a tricky question, but a very, very important one.
Yeah.
Thank you, Thomas.
Okay, that was
so
fun.
much.
Yes, it was very interesting, and I think we can agree to disagree. And as you said, everything is experience, and I hope you get a great experience with our talk today, and hope to see you in our next sessions.
Thank
See you next time.
Thank you all for participating.
Thank you. It was very interesting.